Hello and welcome back to tutorial 36. If you've not seen the first video associated with this tutorial, then it may be a good idea to do so. We're demonstrating the use of GlobalVariable.DLL to pass data from radar screen to a chart, and in the last video I mentioned that since the radar screen was set up to not update intrabar, that there was a possibility that the receiving chart may receive the data before it was sent, and in that way be about a minute out of date. I also mentioned that one way of solving this would be to have the radar screen updating intrabar, and so if the chart did happen to receive data before the data was sent, then at least it would only be a tick or so out of date. But we're going to be looking at a different way of doing that, and in this way we're going to be on the chart just adding a little bit of delay before the chart uses the global variable to retrieve the information. So let's just look at the programs and hopefully everything will become clear. Firstly, the radar screen, we've got an indicator called send data applied to that, so let's open up send data, and you'll notice straight away that we've got this define DLL func at the top here, and we didn't have this before because we were using the easy language wrapper functions to access the global variable, and I just wanted to show you how you could do that without using the wrapper functions. And you'll see down here we're using gv underscore set double, and that is not using the wrapper functions, so we have to use this define DLL func at the top here. And if this doesn't make sense, I suggest, as before, that you download the GlobalVariable.DLL and install the easy language functions and look at the workspaces that are included in that zip, and then you will see some examples of how this all works, and you may be able to open the wrapper functions, and then you'll see this define DLL func. So anyway, let's just go through this program. Again, we're looking at the last bar on chart, and remember this is applied to the radar screen, and again we're setting the GF set float to the number of the row. Remember that get app info AI row finds the number of the row, and we're setting it to the close of that particular stock. Now, just for debugging purposes, what I also did was added this little routine here which says get symbol if get symbol name equals IBM. In other words, this is only going to be done if we're on the IBM row of radar screen. Then we're going to grab the computer time. Now, computer date time gets the time from your computer clock in date time format. Date time format returns the date as a number since 1900 to the left of the decimal point, and to the right of the decimal point it calculates the fraction of the day. So for example 0.5 would be midday. Anyway, we get that time and we set it as a double into the number double 1 and compute time, and then we're also just adding a print statement which shows the computer time on the sending function. So that is the sending function. On the chart, let's just have a look at the chart here. We have got an indicator receive data applied, and let's just open receive data and see how that works. So setting up some variables here and the divisor as before. Now in this case what we're saying is if it's the last bar on the chart and the last tick of that bar, then we're going to grab the computer time and we're going to set this thing data received to be equal to false. Now then, if we go down further in the program, we'll see if the last bar on chart and data received is false. So data received, just make sure that we just don't do this more than once. And then in order to create the delay, what we've added here is we've said computer date time has got to be greater than current time. Remember, current time was the, or rather cur time, was the time that occurred on the last bar on chart, bar status equals to 1. If the computer time is greater than that plus, and then we added a little delay in time, and I've calculated that 24 hours times 60 minutes times 60 seconds, so we've just added a 10 second delay there. And when that delay has taken place, what we do is we reset sum to 0. We've got a little print statement there which is grabbing the computer date time that was set in the sending function. It's also grabbing the IBM float value from global variables, which should show us what the IBM price was at that time, and it's also showing the difference between the computer date time and the value that was set in the sending function. So that's just there for informational purposes. You don't need that for the program to run. So having done that, we're at the last bar of chart, the data received is false, and a little bit of time has passed. Then we go through and we add up and we get all the data from getFloat. We create the sum using that, and we set the data retrieved is true so that we don't go through this again. And then, similar to the program I demonstrated in the first video, we then go through and we do a plot. If sum is 0, we just plot the close. If we've started receiving global variable information, then we plot the sum divided by the divisor, and we put that on the chart. And as you'll see, if we just go back to the chart, you'll see that prior to the application of this using live data, we've got this black line which is just plotted on the close values, and we start plotting the yellow line as soon as the information starts coming through from global variables. And just to explain some of that debugging information, we can see here that the send function has sent a value of IBM at 14:15 of 125.92, and the computer date time that it was sent out was 401.26.593738. And then you'll notice there was a little gap there before we got the receiving information. The time obviously is the next bar, but you can see that the computer date time passed through that double global variable is exactly the same as the sending function, and the price is exactly the same, and there we can just see the amount of time that that took to come through. So if we were just to wait for another minute, say, we would see another send function. There we go. And then a few seconds later, because we added this gap into the proceedings, we will get the information received. And there we have it. So anyway, that was a very quick run through on some additional modifications to this program, just to make sure that the receiving function does receive the data after the sending function. As I mentioned, this could also be done in a few other ways, but I think it's useful just to demonstrate how we can add a little gap into the processing of our program. Anyway, I hope you found that useful. If you're not a member of our email mailing list, then please go to markplex.com, markplex.com, and join the email mailing list there. Thank you very much.